Hi class. So in our last video we talked about game theory. We introduced total conflict zero-sum games, and we introduced a tool to look at them called payoff matrices. Today what we're going to do is see how we can use a payoff matrix to determine good strategies for playing games. So I want to start out with an example today. The first example is a game between Henry and Lisa. So Henry and Lisa are building a restaurant. And Henry wants to build it at a high elevation, while Lisa wants to build it at a low elevation. And so to compromise, they decide they're going to play a little game with each other. So there are 3 routes in the town. There's route A, route B, and route C. And it crosses 3 highways in the town. There's highway 1, 2, and 3. So just for a picture, here's highway 1, 2, and 3. And over here, here's route A, B, C. And so they decide that Henry will choose a route, and Lisa will choose a highway. And whichever intersection they get from that route and the highway, that's where they're going to build their restaurant. So for instance, if Henry chooses route B and Lisa chooses route C, then where are they going to build it? Well, we just trace B over here, and then we trace 3 down, and so they're going to build it over here. And this is where their restaurant will go up. Okay, and so, well, why do they do it this way? Well, it turns out the town is at very different elevations, and so this is a flat picture, but that's not really the case. Okay, over here at this intersection of A and 1, it's 10,000 feet high. At the intersection of A and 2, it's 4,000 feet high. Intersection of A and 3 is 6,000, and so on, as we see below. So what I want to think about is, suppose we're Henry or suppose we're Lisa, then which road should we take to try to get as high of an elevation or as low of an elevation as possible? Remember, Henry wants a high elevation, Lisa wants a low elevation. Okay. Well, to analyze this, you can see it's actually already kind of a game matrix. So let's just make that official. So we'll have player 1, Henry, and he chooses between routes A, B, and C. And we have player 2, Lisa, who chooses between highways 1, 2, and 3. And we'll just copy the scores in, the scores just being the height at which the restaurant will be built at each of these intersections. So it's 10 here, 4, 6, 6, 5, 9, 2, 3, 7. So there's actually a lot of things to think about in this game. Remember, so Henry wants high elevation, wants high numbers, and Lisa wants low numbers. So if we go ahead and we think about, well, what's the best score Henry could get? The best score Henry could get would be this 10 over here. But how would he get that? Okay, so again, Henry can choose one of these 3. And so to get the 10, Henry would need to choose A, and then Lisa would have to choose 1. And that would lead to them building the restaurant at the intersection of height 10. On the other hand, what's the worst that Henry could do? I guess the worst that Henry could do would be to get this score of 2 down there. That's the lowest elevation. And so he would get that by choosing C and by Lisa choosing 1. So you might think, okay, well maybe Henry should avoid playing C, right? Well, that's a reasonable idea. But if Henry avoids playing C, then he might never get this payout of 7. C allows him to get either 2, 3, or 7. If he avoids playing C always, then he'll never get those outcomes. In particular, he can't get that high outcome of 7. All right, and so what about Lisa? Well, Lisa wants that really low score of 2, but Lisa will only get that by playing in column 1. That is picking highway 1. And that's a little bit risky because, again, if she picks highway 1 and Henry picks route A, well, then they could be in trouble, right? Lisa's going to end up with that restaurant built very high up. Okay, and so you can see there's kind of a dynamic back and forth that's gonna happen when deciding which route to choose and which highway to choose. So what I want to focus on is the following question. What is the highest elevation that Henry can guarantee? And what do I mean guarantee? Well, again, he can't choose which highway. He can only choose the route. So let's take a look one by one through the routes. So suppose he chooses route A. Well, then his options are either 10, 4, or 6. And so if he chooses route A, Henry guarantees a height of 4, because that's the lowest one that could possibly happen. He could get 6, he could even get lucky and get 10, but he definitely gets at least 4. So 4 is called the row minimum, because it's just the smallest value in the entire row. Okay, what if he chooses instead route B? Well, then he could either get a height of 6, 5, or 9, but notice now that he guarantees at least a height of 5. And again, he could get a height of 9, he could get a height of 6, but all of these numbers are at least 5. So if Henry chooses route B, he gets at least that score of 5. And again, that's the minimum of the row, it's the row minimum there. And finally, if we go to choose route C, right, well, then he could end up with this height of 2, 3, or 7, and so you're only guaranteeing yourself a height of 2. Again, these are the worst case scenarios in each row, but we have to take into account the worst case because we can't choose which column we're going to be in. So we have to look through column 1, column 2, and column 3 and see which of those is the worst out of the 3, because we have to prepare ourselves for kind of that possibility. And so what's the best score that Henry can always guarantee that he'll get? It actually turns out to be 5, right? Because he could get 4 by choosing route A, he could get 2 by choosing route C, but if he chooses route B, he always gets a score of at least 5. Let's write that down. And so we should give this number a name. It's actually the maximum of these 3 row minimums. So we're going to call it the Maximin. And again, the way I sort of remember it is it's the max of the mins. And if you just say that really quickly, maximins, 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 it actually sounds like maximin. And so what this maximin value is giving you is it's answering this question that we just posed up here. It's the highest score, or the highest elevation, that player 1, Henry, can guarantee. Notice that it's not going to give Henry the top score being 10. You're never going to get 10. You're going to guarantee yourself at least 5, with the possibility of getting 6, with the possibility of getting 9. Okay, on the flip side, let's think about how Lisa can play this game. Remember, she doesn't want a high score, she wants a low score. So what is the lowest elevation that Lisa can guarantee. And again, she can't choose the root or the rows. She can only choose the highway. Well, we'll just analyze this in a very similar way. What can happen if she chooses highway 1? Well, then she could get really lucky and end up with that really low elevation of 2. But she could get very unlucky and end up with that high elevation of 10. So the worst case scenario for Lisa in column 1 is a score of 10. So guarantees a height less than or equal to 10. Okay, and that's not really good at all, right? 10 is the worst number you can get. So I'm just going to write 10 down here. And what was that? That was the maximum of the column. So this we'll call column max. And so it's giving the worst case scenario for player 2 in player 2's choice of that column. Now we'll go ahead and do that for the other columns. What happens if Lisa chooses highway 2? Well, the worst case scenario then is going to be a 5. It's the maximum of the entries in this column. And that's at least a lot better than a 10. Okay, now what about highway 3? Well, the worst case for Lisa in highway 3 is a score of 9. Again, that's the maximum in the column of this number. And so, which column should Lisa choose? Which highway should Lisa choose? Well, she could choose the one that guarantees an elevation of at most 5, and that would be going with column 2. And so the column maximums were 10, 5, 9. And the minimum value of the maxes is 5. And so that's just to say that Lisa can guarantee a score of at most 5 by choosing highway 2. And what are we going to call this? I'll give you a little bit of time, maybe you can guess it. It's the min of the maxes, so we're going to call this the minimax. You know, I didn't invent this terminology. I understand how confusing it's going to be, Maximin and Minimax. Again, just try to think of the translation. The maximum of the minimums and the minimums of the maximums. I know you're probably going to go crazy. Sorry. Okay, so all of this is to say that if both Henry and Lisa want to play relatively safe, they don't want to take any risks, they just want to sort of guarantee themselves a value that they can bank on, then Lisa should be choosing highway 2. That's her minimax strategy, is to choose the column that gives the minimax value. And likewise, if Henry wants to kind of play it safe, wants to guarantee, so he can plan ahead and say, okay, I know the elevation is not going to be more than or less than this, then Henry should choose root B, because that's how he guaranteed the height of at least 2. And that's called the Maximin strategy, choosing the row that gives the Maximin value. Okay. So in this example, both players actually achieve their Maximin and Minimax value by playing their Minimax and Maximin strategies, right? Because they actually, these two selections actually intersect at that value of 5, which is exactly sort of the worst case scenario for both players in that row and that column. This is a special case where the Maximin actually equals the minimax, so both players can guarantee the same score. In this case, 5. When this very special thing happens where the maximin equals the minimax, we say that 5 is a saddle point. Now we'll see in a second why it's called a saddle point, but for now what I want you to notice is that when there's a saddle point, both players' safest strategies, their Maximin and Minimax strategies, produce the same outcome. Now I want to throw a definition out there. The value of a game is the score that both players can guarantee. So in this case, both players can guarantee a height of 5, at least 5, or at most 5, depending on who they are. And so the value of this game is 5. And in particular, whenever we have a saddle point, it will always give us the value of the game. Now you have to be careful. There isn't always going to be a saddle point. Remember, the maximin being equal to the minimax is actually a special occurrence. It's not generally going to be the case. But let's try to interpret what the value of the game means a little bit more in this example. So we have the maximin row and the minimax column. And the point is that, well, Henry is never going to get the best score of 10 using this strategy. And Lisa is never going to get that least score of 2 using this strategy. But Henry knows that he can get at least 5 with a possible chance at 6 or 9 by choosing row B. And likewise, Lisa knows that she can get at most a score of 5 with chances at having it built at 4,000 and 3,000 feet instead by choosing column 2. Since they both know that they can guarantee a score of 5, that is, they know the value of the game is 5, Henry will feel bad if he ever scores less than 5 because he knew that he had a foolproof strategy to get at least 5. So if Henry ends up with 4, then Henry will be very upset. Likewise, Lisa knows that she can get at most a score of 5. And remember, Lisa wants low numbers. And so if she ends up with a score of 9 or a score of 6, she'll be upset. So take a look at what happens with this game once both players have figured this out. Well, Henry has no incentive to depart from B, because if he guesses correctly that Lisa is going to be conservative and play for minimizing her loss, then he realizes that Lisa will play highway 2. And once Lisa plays highway 2, Henry has no choice but to choose route B, because Henry can choose route A, but that would lead to a score of 4, which would not be as good as a score of 5. Or he could choose route C, which would lead to a score of 3, again, not as good as 5. So Henry actually is forced into choosing route B to get the highest score possible in that column. Likewise, once Lisa knows that Henry is playing his Maximin strategy, she has no incentive to depart from column 2. If she chooses column 1, it's only going to be a worse outcome for her. And if she chooses column 3, same. Then she'll end up with that score of 9, which is again worse than 5. So when you have this saddle point, both players are incentivized to stay at their choices. They've sort of sunk into the saddle. So you might be wondering why it's actually called a saddle point. And so let's take a look at these numbers up close. So we got 4, 5, and 3, and 6, 5, and 9. So let's try to draw a picture of this town, what it actually looks like. Okay, so this is route B. This is highway 1. rather highway 2. And so what does route B look like? Well, it starts at an elevation of 6, and then it drops down to an elevation of 5, and then actually goes up to an elevation of 9. So if you're just driving along route B, you dip down a little bit, and you come back up. Now what about highway 2? Well, it starts then at an elevation of 4, so maybe this is like 4 above there, goes up to an elevation of 5, and then goes back down to an elevation of 3. And so, well, what does this shape look like? Well, it looks just like a horse's saddle. You can tell by my very artistic rendition over here. And so that's why this is called a saddle point. It's the lowest point along one route, but it's also the highest point along another route. And so it sort of forms this nice, beautiful saddle shape. And there we go. So we've seen how once we have these payoff matrices, we can analyze them by finding row minimums and column maximums and use those to find minimax and maximin strategies. And with those maximin and minimax strategies, we can find the value of a game, that is the score that kind of can always be guaranteed by both sides. And we can find that if the game has a saddle point. If the game doesn't have a saddle point, then we might not be able to tell what the value of the game is. We'll actually have to wait for a few more classes to learn how we can still solve for values of games, even if there is no saddle point. In the worksheet, you're going to be finding maximin and minimax values. You're going to have people playing their maximin strategies, their minimax strategies, and trying to find out what the outcome will be if both people choose those strategies. What I just want to drill home is that player 1 chooses rows and player 2 chooses columns. And so when you're playing your maximin strategy, that means you're choosing the row that gives you your maximin value. So Henry playing his maximin strategy was to play route B. Lisa playing her minimax strategy was to choose highway 2. And the end result of that was them achieving the outcome of 5, which happened to be both of their maximin and minimax values. All right, thanks for listening. Take care.